Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. Looking at the big picture, we are working on memory and storage. It's a red topic. In particular, binary shifts. So if you pause the video and take stock of where your knowledge is right now on these two bullet points. Once you're happy you've done that, if you fill in the ticket in your green book, and now we're ready to learn. A binary shift is a CPU instruction. It's an instruction that the CPU performs on a byte. There is a left binary shift and there is a right binary shift. What does the word instruction mean to you? Maybe pause the video to think about this or look it up. So I have looked up this word and I have found a definition that comes very close to our use of the word instruction in computer science. So an instruction is giving the steps that must be followed. So we're going to go through the steps that must be followed in order to perform a binary shift on this byte. First of all, can you work out what this number is in denary? Of course you can, it's 12. We have 8 has got a 1 underneath it and so has 4. So 8 plus 4 is 12. The 128 column is the most significant bit and the least significant bit is the ones column. And we're going to be using this terminology throughout this video. Okay, let's get on with it. I'm going to apply a one place right shift to this byte. Step 1, move all the bits one place to the right. Okay, let's do that. And that's done. Step 2, drop the least significant bit. Okay. And that's done now. Finally, step 3, fill in the most significant bit with a 0. Well, if you notice, there's just a gap there now. So I've done that. And that is our binary shift complete. Why does the CPU do this? What was the point in that? Well, we're going to find out now. So we started with 12. We moved all the bits one place to the right, and we ended up with 6. So what we have done is we have divided by 2. And that is what the CPU is doing. A binary shift right one place divides the number by 2. And this is an integer division. It's whole numbers we're dealing with in this topic at GCSE. What do you think would have happened if I'd moved those bits 2 places and not 1 place? Well, let's find out. We would have gone from 12 to 3. So a binary shift right 2 places divides the number by 4. And now I'd like you to have a go at applying a binary shift right one place to the number 9, and the byte or the binary equivalent of 9 is 00001001. Pause the video and have a go. Okay, and now I'm about to reveal the answer. So this time round, we started with 9 and we ended up with 4. We actually dropped a 1 this time, not a 0. So we've done 9 divided by 2 and we've got 4. Is that correct? Could it be correct? Well, 9 divided by 2 is 4.5 or 4.5. However, we're only dealing with integers, which are whole numbers, so we need this answer in a whole number. So if I've got 4.5 and I want to show that as a whole number, so no decimal places, I can round up or round down. And the binary shift rounds down. So 4.5 rounded down is actually 4. So that is actually the right answer. Let's move on. This is the point now to take stock of what you have learned so far and to take notes in your green book. So this is something you can take away from our lesson. I have given you an example here of a binary shift right one place. We start with 170, it gets divided by 2, so we end up with 85. And on the right here, we can see it's explaining what's happened, that the bits have all been moved to the right, the least significant bit is dropped, and the most significant bit is given a value of 0. This results in the number being divided by 2. So if you want to pause the video, take these notes down, press play when you're ready to get back to the lesson. Okay, so now we're going to do a binary shift left one place. And we're going to use 12 again, so the binary value for 12. And I would like you to pause the tape or pause the video and have a go at doing this. So how did you do? So we have moved all the bits one place to the left, and now we are dropping the most significant bit. And the least significant bit here has got a gap, so we're going to fill that with a 0. And that is the left binary shift complete. So again, what was the point in that? What has been achieved? Okay, so we started with 12. We did a left shift one place this time, and we ended up with 24. So what has happened is the number has been multiplied by 2. What do you think would happen if we had done the shift 2 places to the left? I'm sure you got this right. That would have actually multiplied the number by 4. Again, time to take stock of where you are now with your knowledge, and a takeaway again for your green book. This time we're looking at a binary shift left one place. So again, I have taken a value, this time 15. I've represented that in binary, and I've shown you that after a left shift one place, we have ended up with 30, so double the number. So on the right here, you can see that this describes what has just happened, that all the bits have moved to the left, the most significant is dropped, the least significant is given a value of 0, and this means we have multiplied by 2. So pause the video to take down your notes. And that is it for the learning in this lesson. So how did you do? Where do you think your knowledge stands now? Fill out the ticket in your green book. I hope you've enjoyed learning about binary shifts, and I hope you have made progress in this lesson. Thank you.